Welcome back. In our first module, we explored the geological and engineering foundations of oil and gas production, from how hydrocarbons form in the earth, to exploration, drilling, completion, and the first flow of fluids to the surface. In this second module, we will shift our focus entirely to what happens once hydrocarbons reach the surface. This is the realm of surface production technology, the systems, processes, and infrastructure that separate, treat, measure, transport, and prepare oil, gas, and water for sale or further processing. We will also look at production optimization, artificial lift, flow assurance, environmental protection, and health and safety requirements in the oil field. By the end of this module, you will have a solid grasp of how production facilities operate, how fluids are handled from the wellhead to the point of sale, and how operators maintain efficiency and safety in the complex environment of oil and gas production. 1. The journey from wellhead to market. When oil or gas emerges from a well, it is rarely in a pure form ready for market. Instead, the production stream is a mixture of crude oil, natural gas, formation water, and often solids such as sand. The first point of control is the wellhead, a robust assembly of valves, spools, and fittings that regulate flow and allow for safe shutting of the well. The wellhead leads to a structure called the Christmas tree, which houses the valves that control production and access for monitoring and interventions. From the wellhead, the multiphase flow is directed into the production facility for separation and treatment. The layout and complexity of these facilities depend on factors such as the composition of the produced fluids, production rates, and whether the operation is onshore or offshore. 2. Separation of produced fluids. The first major processing step is separation, splitting the well stream into its primary components, oil, gas, and water. This is done using equipment known as separators, which use gravity, pressure differences, and sometimes centrifugal forces to divide the fluids. A typical three-phase separator will have an inlet section where the mixture enters, an oil compartment, a water compartment, and an outlet for gas. The separation process allows each phase to be treated and transported according to its own requirements. Separators are often operated under pressure to prevent the gas from expanding prematurely. Downstream of the separators, gas is dehydrated and compressed, oil is treated for impurities, and water is disposed of or reinjected. 3. Oil processing and stabilization. Crude oil straight from the reservoir often contains residual water, dissolved gases, and impurities like hydrogen sulfide. Before it can be transported, it must be stabilized. Stabilization involves reducing the vapor pressure of the oil so that it can be safely stored and shipped. This may be achieved by heating the oil, flashing off light hydrocarbons, and removing unwanted contaminants. In onshore facilities, oil is typically sent to storage tanks before being pumped into pipelines or loaded onto trucks. In offshore operations, stabilized crude may be stored in floating storage units or exported directly via subsea pipelines. 4. Gas processing and conditioning. Natural gas from the wellhead contains not only methane but also heavier hydrocarbons like ethane, propane, and butane, as well as impurities such as water vapor, carbon dioxide, hydrogen sulfide, and nitrogen. Before gas can enter a sales pipeline, it must meet strict quality specifications. Processing steps may include dehydration, removing water vapor to prevent pipeline corrosion and hydrate formation. Sweetening, removing acid gases like hydrogen sulfide and carbon dioxide. NGL recovery, extracting natural gas liquids, NGLs, like propane and butane for separate sale. Compression, raising the pressure for pipeline transport. Gas processing plants vary in complexity, but their aim is always to produce clean, dry, specification-compliant gas. 5. Produced water handling. Produced water is an inevitable byproduct of oil and gas production. It often contains dissolved salts, hydrocarbons, and other contaminants, making it unsuitable for direct discharge. Produced water handling involves separation, treatment, and either disposal or reinjection. Disposal options include deep well injection or discharge to the environment if it meets regulatory standards. Reinjection is often used for reservoir pressure maintenance, part of enhanced oil recovery strategies. 6. Artificial lift systems. In Module 1, we saw that early in a field's life, reservoir pressure is often sufficient to drive fluids to the surface. Over time, however, natural pressure declines, and production must be assisted using artificial lift. There are several artificial lift methods. Beam pumping, the classic pump jack system, widely used in onshore fields. Electric submersible pumps, ESPs, high-capacity pumps installed downhole, suitable for large volumes. Gas lift, injecting gas into the production tubing to lighten the fluid column and enhance flow. Progressing cavity pumps, PCPs, suitable for heavy oil and viscous fluids. Choosing the right lift method depends on production rates, fluid properties, and economic considerations. 7. Flow assurance in oil and gas production. Flow assurance is the discipline of ensuring that hydrocarbons can be transported from the reservoir to the processing facility without blockages or interruptions. Challenges include hydrate formation, ice-like solids formed when gas and water combine under certain conditions. Wax deposition, paraffin waxes can precipitate and clog pipelines. Asphalting deposition, heavy organic compounds that can settle out and cause blockages. Scale formation, mineral deposits from produced water. Preventing these problems requires a combination of chemical inhibitors, heating systems, insulation, and careful operational control. 8. Production optimization and surveillance. Maximizing production requires constant monitoring and adjustment. Operators use sensors and control systems to track pressures, temperatures, flow rates, and fluid compositions in real time. Production engineers analyze this data to identify underperforming wells, optimize choke settings, adjust lift systems, and schedule maintenance. Field optimization is an ongoing process. The aim is to achieve the highest possible recovery at the lowest cost, while maintaining safety and environmental compliance. 9. Health, safety, and environmental considerations. Oil and gas production is inherently hazardous, involving high pressures, flammable materials, and complex equipment. Safety is therefore paramount. Operators follow strict safety management systems, including hazard identification and risk assessment, emergency shutdown systems, fire and gas detection systems, personnel training and safety drills. Environmental protection is also a major concern, with regulations covering air emissions, water discharges, waste disposal, and spill prevention. The industry increasingly emphasizes sustainability, seeking ways to reduce greenhouse gas emissions and minimize ecological impact. 10. Interface with midstream and downstream sectors. Once oil and gas have been processed to meet specifications, they leave the production facility and enter the midstream sector for transportation to refineries, petrochemical plants, or LNG terminals. Crude oil is typically transported by pipeline, tanker, or rail. Natural gas is moved via high-pressure transmission pipelines or, in the case of LNG, by specialized refrigerated ships. At this point, responsibility shifts from the production team to transport and refining operations, but the quality and reliability of production remain crucial to the entire value chain. In this module, we have completed the journey of oil and gas from the wellhead to the point where they are ready for market. We examined separation processes, oil and gas treatment, produced water handling, artificial lift, flow assurance, production optimization, safety, environmental considerations, and the link to midstream transportation. Together with Module 1, you now have a complete overview of the upstream production process, from subsurface geology to surface processing. This knowledge forms the foundation for more advanced studies in petroleum engineering, production operations, and energy management.